So this demineralization process is the initial process where you put a water into boiler or in steam generator, then you start generating steam, start utilizing it on a steam turbine or in your process, recover back condensate, and this condensate you want to put it back into boiler as a feed water. So it becomes a cycle. But there are some losses in this entire cycle. You need to keep making up some this DM water. So you generally have a DM plants which are common between 4 or 5 boilers or 4 or 5 power stations where water is make up continuously to make up losses in this cycle in terms of blowdown, vents through deaeration. Those are makeup is made using this DM.
Okay. That's an interesting way to look at it. Okay. The technology is actually quite advanced, and as you mentioned, I mean, it does tend to be expensive as it progresses in terms of its sophistication. But this is necessary. This is not something that we can simply avoid. Okay. So, for example, you just mentioned one thing which kind of stayed with me, which is that even if you have a small area where you have some salt being deposited, that can start local corrosion.
Yeah, it can cause local corrosion. Local deposition can even create local hotspots.
Right.
So you can see these tubes can overheat at a particular location. So there are a lot of failure mechanisms start.
Yeah. And as the temperature goes up, you have creep, you have fatigue settling into those specific zones, right?
Yes.
Yeah.
So a lot of forensic study also goes into that. Actually, our lot of users who operating this power plant also got their own laboratories to not only ensure that water purity is maintained, but if there are failure, they can do root cause analysis. So a lot of chemistry goes in this process.
Okay, fair enough. Fair. So the next question I had, I mean, this is something of a curiosity of mine, which is if we are talking about demineralization technology, which is already a more or less mature technology, do you still see any gaps, both in terms of technology or the techno-commercial aspects, which we talked about earlier, where if this one thing, if it could be worked or it could be solved, it will actually have a beneficial impact on the overall process of water chemistry?
Yes. So if you say demineralized plant, as I mentioned earlier also, any ideal technology, when you implement in an industry, you don't just think about implementing it once, but operating it over the time 24/7. So major problems come in when you start operating these demineralized plants over the year. Because over the year, take example of India, we have a lot of good rainfalls. So suddenly water comes with, river water comes with the mud. Mud is nothing but silica. And silica is one of the cause of deposition. Okay. It will come with a higher hardness. So you need to treat water more frequently. You need to change resins more frequently. You need to clean them, regenerate them more frequently. So when you go into operation of these plants or boilers or DM plant, then you need to work a lot in optimizing operation aspect. You are not just limited to technology, but how you will efficiently operate it over long period of time. Because power plants are designed with a payback of 30 years, 40 years.
Right.
Okay, so this is big investment as a nation, any nation or investor is doing in this power plant. So they want to operate it continuously, efficiently, round the clock, without any forced outages, forced downtimes. And that's where, water chemistry and these operational systems come into picture and actually contribute a lot in maintaining these efficiencies and overall cycle chemistry parameters.
So